Hello, Calculus fans. This is primarily for students in my business math course, but this would work for anyone that's learning derivatives. The only thing we don't have here is we haven't introduced trig functions or exponential function or anything. But if you're just wanting to get the basics of how to take derivatives in a good step-by-step of how to approach it, this will work for that. So what I'm going to do is kind of separate the skills. And I think I'll make a little video, a couple short videos to follow this one. But my goal of this video is to help you identify where your confusion is. Okay? So the steps are to prepare yourself to be a calculus student. Calculus students have this, and for this video, I'm just going to talk about this one, have this one main rule, which is that the derivative of x to the n, this is the power rule, the derivative of this is nx to the n minus 1. Though if I want to write it in one step, I don't want the notation to confuse you, but this is how we write it. So the rule is bring down the power and then subtract 1 from the power, and that's it. But in order to use it, you have to have it in a form that you can use it. And that often involves rewriting things in the form some number times x to some power. And so I will make a separate video to talk about that, but it's really quite short. But there's a few skills I'm seeing students make mistakes on in my class. Some don't know that 1 over x to the a is x to the minus a. So some don't know that. And I'll talk about that in a second. Some don't know about roots, that the nth root of x is the same as x to 1 over n. And some students struggle with fractions and how to work with coefficients. So I will, if that's your issue, I will make a short video talking about those particular things. For now, I'm just going to show you what I mean by those. So a student that knows their algebra knows that this is the same as 3x to the minus 5. Now, a lot of students in office hours, that's where their mistake is. And those students should watch my step 0 video. They need to know that the second one is 2x to the minus 2, and they need to know the third one is 6x to the 1/3. If that's where your error is as you do this problem, and I picked a problem from the homework that already a lot of students have attempted. This is one of the most missed problems, and I suspect it's just that first step. So this is preparing you, and it doesn't look pretty. We've written it uglier, but we're preparing it so that we can use our power rule. Okay, the next step is to identify the form. And so in terms of identifying form, what I see is A plus B plus C. This is a sum of separate terms. And when we talked about sums, that's the most fundamental rule. The rule is do each one separately. So basically, I just have 3 completely separate jobs to do. It's as if nothing else is there. I'm going to do the derivative of this, and the derivative of this, and the derivative of this. And I talked about, in addition, the coefficient rule. I didn't actually write this here, but the coefficient rule is you copy down the coefficient. So I can already start to write in my answer. It's going to be 3. That's the coefficient of the first term. And then there's going to be a 2. That's the coefficient of the second term. And then there's going to be a 6. That's the coefficient of the third term. And I like to still tell students that the coefficient and the sums come along for the ride. Notice how I can copy those without thinking. Then we do our power rule, and we're going to do it 3 times. Once for this one, and so right here, and I like to put parentheses here so I don't get mixed up in my numbers, but I'm going to write minus 5x to the minus 6. I subtracted 1 from the power. I'm going to do the exact same thing here, but with negative 2. I bring the power down, and I subtract 1. I'm going to do the exact same thing here, but with a third. I'm going to do 1/3 x. And sometimes this bothers students just because of worry about fractions. But this is the same as 1/3 minus 3/3. And so it's negative 2/3. That's it. Now at this point, I like to, if I was going to type this in, it would be negative 15x to the negative 6 minus 4x to the negative 3 plus 2, because that's 6 divided by 3, x to the negative. So, most students got it right, but this was the most missed question. And so I think it's from step 1. So you can see we identified the form, and as we applied the rule, we had to do some smaller derivatives. Okay, so there is example 1. And I'm just trying to do a couple overarching examples. What I would like you to do is to make a note of, if you were stuck in step 1, watch my follow-up video on this. If you're stuck later, watch other videos where I'll talk specifically about some of these other things. Okay, let's reboot here and try this again. So I'm going to delete a few things from this, and I'm going to grab another question. And this is going to be from our practice page on our exam archive. So on our exam archive, we have a collection of practice problems. Let's pull that into I have 2 problems here. So these are a little bit bigger, and they're more about form. Okay, step 0, prepare for calculus. Are there any x's in the denominators? No. Are there any fractions to pull out? No. Is there any roots? No. So this is more about form. So if I hold this up to this, and some students have a real hard time with this, so the question is, can you write this as a plus b? There is a plus in there and there is a minus in there. It could be a plus or a minus, so it could be a sum or a difference. So you could write this or this. But there is no way to write that as a plus b. So that's out. Can we write it as f times s? We can. This is f. This is s. That's the rule we're going to use. Now, sometimes students go, well, can't you say inside, outside? You can't. You can't write this as everything to the 8th. That's not the same. You can't write it as a fraction. With practice, it takes no thought to realize this is a product. So then you start to use the product rule, and that's one of the rules we've been learning. Plus the derivative of the first times the second. And I don't even have to think. I mean, this can be routine. So you just start filling it in. You say, okay, the derivative. I'm going to write down the first function, which is this. I'm going to write a plus. I'm going to write down the second function. I'm just giving myself lots of space. Okay, now I'm ready to restart. I need the derivative of the second. So let's just, some students have to write it down when they're first doing this, but now I'm going to play the game again as if that were my starting thing. I'm going to take its derivative. And when I'm done, I'm going to put that right here. Okay, so you go, what does that look like? Does that look like a sum? No. Does it look like a product? No. Does it look like a crop? No. But does it look like something to the 8th? Yes. And the rule for this is to bring down the power, leave the inside alone. This is sometimes called the general power rule. And we're going to learn more later. And then you take the derivative of the inside. So let's do that. Bring down the power as if it's a power rule. Make it a 7. And then the key part of the chain rule is to leave the inside alone. And then you multiply that, whatever that is, times the derivative of the inside. The derivative of the inside, now we're finally down to something we immediately know, is 3. We are now done. That's S prime. So if you're stuck on that, watch follow-up videos where I go into some of those pieces in more detail. Okay, so now we're going to do the derivative of the first. So let's grab the first. So you can see how you just parse things up. If you don't know what that word means, break it up into its pieces. This is also a chain rule problem. So it's 2. You copy down to the first. That's this part. And then you leave the inside alone, whatever it is. In this case, it's x squared plus 6. And then you put a little dot, and you do times the derivative of the inside, which is 2x. That seems like a lot. Students get overwhelmed by that, but it's not that bad. You can be able to step back and say, okay, it was... If you try to say it all together, I'd use the product rule and chain rule, you can make it sound complicated. but just you're only dealing with one question at a time. Oh, we'll do one more before I break off into smaller chunks. Okay, let's get rid of that. And let's look at this one. And really, once you've practiced this, nothing should scare you. Yes, it gets bigger, but let's look at this. There is a fraction there, but I cannot write this as, without some simplifying, I can't write it as one big fraction. When I look at this, what I see is A plus B. I see two things that are completely separated by a plus. That's why I have this example in here. And the rule for that is just to take the derivative of each one separately. The derivative of the second one is fairly quick. It's 6x. That's b prime. The derivative of the first one, now I've got some more work to do. So now we're going to restart and say, okay, if you just give me a equals, and I'll erase all this, a equals x squared plus 2x over x squared plus 4x plus 2, and you set it next to these, what does it look like? It doesn't look like a sum, it doesn't look like a product, it doesn't look like something inside of a power. It's a quotient. And then you start applying the quotient rule, which is denominator to the numerator minus numerator to the denominator all over the denominator squared. And the derivative of this is just derivative of the first plus the derivative of the second. This is the derivative of the inside. Okay, anyways, you start applying the quotient rule. We've played this game. It's denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. I know it's a big ugly mess, and that's separate from this. I should have given myself more space. Plus 6x. That's what you're doing. And you can see in the middle of these problems, sometimes I have to do other derivatives. So I think I'll stop that there. There's plenty of places to practice, but what I'd like to do, something new I'm trying, is to break it down. So I'm going to spend quite a bit of time on that first step, because if we can't do the first step, we're just stuck. And then I'll talk individually about some of the